Okay, so Lion, just getting back to just engaging, just a short, quick back and forth. So does the gas mix or does it separate or does it do both?
Both. But it
Okay.
doesn't. People are under the impression it's like a uniform, like completely uniform mixing, homogeneous mixing. No, it's not. There's still stratification, and there's still a pressure differential between the bottom of the balloon and the top of the balloon. And contrary to popular belief, the gases will mix, but there will still be a slight stratification, ever so slightly, because of the limited size of the container. But if you were to scale that container up, whether it's a balloon or propane tank, you're going to notice the stratification. It's going to be significant. And then a small ass balloon, like a birthday balloon, good luck trying to measure that differential, dude. It would be a fraction of a degree, dude. No, it wouldn't be meaningful.
So would it get right? If you made it large enough, would it get near a vacuum at the top?
Yes.
Why?
Gravity.
That was good.
I'm serious.
I did not see that coming.
I know that was so good.
Wait, what do you mean? What do you mean?
I said what I said.
Line, elaborate.
It's a natural phenomenon.
So there's going to be a lump of
fall to the ground. The very thing in question, though, right, is the cause of gravity. Newton said it was mass attracting mass. Einstein said it was the bending and warping of space-time. I think it's neither. I'm still looking for the cause of gravity, why things fall to the ground. Do I deny the phenomena of things falling to the ground, i.e. gravitation? No. What I deny is what you guys presuppose is the cause. Newton said it was mass attracting mass. Einstein said it was the bending and warping of space-time. So the thing that we debate is the cause, which you guys have still not isolated, yet you're so confident that you know exactly what's causing gravity. You have it all figured out.
Yeah, but it's easier to make us look bad if they say that, we don't believe in gravity. That's what they do. That's how they win their argument. In the minds, uninformed masses.
Well, you couldn't have a flat plane if gravity was true.
Why not?
Because if gravity was true, it pulls everything to itself and it would form into a ball or a sphere.
How do you know that?
Oh, so wait a minute. Now you're claiming that gravity creates spheres?
Yes. That is the lowest energy state.
Line, would you mind if I went down the crisis in cosmology with this guy? Because he started with the wrong place.
Doug, take it over, bro. You're fine, dude. I said what I had to say, dude. I'm good. I said what I had to say.
You want to climb this hill with me, that gravity is the reason that the Earth is...
You're breaking up, so I don't know what you said at the end.
Okay, you said that the reason that the Earth is a sphere is because of gravity. So gravity creates space balls, right?
Gravity pulls everything to the center of a mass, yes.
Okay, so gravity creates space balls then, right?
I don't know what you mean by space balls, but gravity pulls everything to the center of the mass.
Okay. You think that there's spheres in space, right?
Yes.
So a sun would be a space ball? Okay. Jupiter would be a space ball, right?
It would be a planet, but yeah, they each have their own gravitational field that pulls the matter to it.
Okay, so you know that 96% of the universe is dark matter and dark energy. Dark matter is put there because we can't explain the expansion rate of the universe speeding up. That's dark energy. And dark matter is the shortcoming of gravity at the galactic level. So you know that gravity doesn't work at the galactic level.
Why doesn't it work at the galactic level?
Because they had to put dark matter there as a placeholder for the anomalies, because according to the scientists, galaxies spinning 10 times too fast, and there's not enough mass to create enough gravitation to hold the stars near the outer rings of the galaxy. So that's why there's dark matter halos around galaxies. Did you know that?
To straw or steelman what you're saying, or to better explain it, there are galaxies that are rotating faster or are not explained. So their best explanation now is that there is what's called dark matter that accounts for the other gravity or mass that they can't come up with, or that we can't see.
But if that's not there, then that means that gravity doesn't work, right?
That means that we would have to further refine that or come up with a better solution.
Hey, can I step in?
Yeah.
So
please.
we don't. Go ahead.
Larry, you think scientists can weight a galaxy?
No.
You think scientists can tell exactly how far a star is?
No.
Right, so maybe that's where the problem is, right? Because the dark matter and all that is only a problem if they are doing these things that you don't think they can do correctly.
So could be anything else, but it can't be that gravity doesn't work. Is that what you're saying?
No, that's not what I'm saying.
Okay, so it could be that gravity doesn't work, or instead of having a space-time continuum, you have an ad hoc continuum. Which one is it?
I don't know what the letter is.
Ad hoc continuum means that every time we find something that doesn't go right with our belief about gravity, just make some shit up in order to fix the model.
I'm not suggesting that.
Okay, so it could be that gravity doesn't work at the galactic level, right?
Yes, could be.
Okay, so can we falsify dark matter?
I don't think so. Currently, I don't think so.
So if we can't falsify dark matter, then it could just be just a placeholder for the anomalies. Have a good day, bro. Gravity and its shortcomings.
Could be, yeah.
So if gravity could have shortcomings, gravity is not a force, and it's so weak that you need black holes and dark matter to make it appear to work, only in appearance. Good night. Sorry, did he not want to continue to the top of the mountain with me?
He left.
Oh, I thought we were going to the top of the mountain together. It's unfortunate. Gave him an out. Good job. Way to be a team player.
Yeah, I mean, what's the cause of gravity? The cause is inconclusive.
At this point, it's funding. It's grants going to the college. Go ahead, bro.
I think it's the unifying force, though. It's responsible for the density in all the elements, and what you guys call the nuclear force or the Euler forces, the intermolecular forces. What is that? What's holding everything together? Yeah, what's holding everything? What's holding all the elements together?
Like the subatomic forces?
Yeah, you guys are looking for the unifying force, right?
I'm not. I don't know who you guys are. Certainly not one of them.
What's the unifying force, though, that will merge quantum and cosmic scale together? What's that?
It's the unified field theory.
Yeah. It's not a force, though, is it? It's just a unified model.
No, it's a force. Yeah, it's interesting because Einstein says it's not a force, but they're starting to look into electrodynamic field theory, and they have to at least pretend it's a force, because otherwise the equations don't work.
Which equation? I'm
not a mathematician, dude. I just know from electrodynamic field theory, the electrons, they have real centrifugal forces, not pseudo fictitious forces like in relativity. They're actually real forces. You never heard that?
The electrons? Yeah, the negative charge, they have electrostatic forces.
Yeah, I'll try to pull up a paper.
Real force. I'm playing a game. I'm not gonna read an article now.
Yeah, the centrifugal force is a real force in quantum field theory. It's not pseudo like in relativity. Centrifugal forces are real forces, real dynamic forces at the quantum scale. Where in orbital mechanics, it's a pseudo force. It's a big deal, dude.
Yeah, but they try to any way they can to like reify gravity and make it concrete, free of gravity. So they say centrifugal force is a pseudo force, but it's really not.
Okay, what acts on the like if I'm spinning something with a tether with this string, what's acting on the object that I'm spinning? I'm rotating. What force is acting outwards from that object?
Centrifugal force is pulling outward, while the tether is pulling inward.
Okay, what is doing the outward pulling?
The centrifugal force?
Yeah, what is causing the centrifugal force?
You just spun it around.
Let's say I have a rock and it's tied to a string and my hand is holding the string, then I rotate the rock around my hand. You're saying there is an actual centrifugal force on the rock pulling it outward, right?
Because if you let go, what happens?
It continues in the tangential velocity that it was moving when I released it, not outwards, perpendicular to outwards, right?
I think that's true. I think what you said is true.
Yeah, so like
but you can measure the force you can measure the force by putting a tension scale in between the rope, right? You can measure that centrifugal force, right?
Yes, but that's pulling the rock inwards, not outwards. That's a
No, the tether is pulling it inwards. Tether is what is pulling it inwards. If you release the tether, it flies away.
Yes, but it doesn't fly outwards. Like there's nothing pulling the rock outwards. The rock is moving tangentially to the center point, and the string is pulling the rock inwards. There's nothing pulling the rock outwards. That's why there is no centrifugal force. However, if you start rotating... Mm-hmm.
So you're telling me there's no such thing as centrifugal force?
Yeah, not in this scenario. The scenario there is no force.
Give me a scenario where there is a force.
Right. So let's say same scenario, I'm rotating the rock around my hand. Now, someone watching starts, for some reason, spinning with the rock. So that person starts rotating with the rock. So from that person's view, the rock stopped moving. And now I'm rotating, right? In that reference frame, there is something that has to pull the rock away from my hand. Otherwise, the string will just pull the rock towards my hand. Because in their perspective, the rock isn't orbiting my hand anymore. So there is no explanation for why the string is pulling the rock, but the rock isn't getting any closer to my hand. So in the frame of reference of that person, there seems to be a force pulling the rock outwards. That's why we say that in their frame, there's a centrifugal force. There's a pseudo force because it only exists in that person's frame. That's the idea of a pseudo force.
Thank you for explaining that to me, Bacon. You explained it really well. Now I know why you guys say that.
Oh, thank you. Well, that's nice.
It's not always about dunking. Sometimes it's about learning. Please continue.
I don't think I had anything else. That's like if
I was talking to Lion because I interrupted him. Oh, go ahead. You have something else.
Well, I'm trying to find it right now, but I'm getting conflicting papers here. Some saying that electrons don't have centrifugal forces. It's also pseudo and fictitious at the quantum scale. But yet you have other papers suggesting that they do conserve angular momentum. Therefore, do have centrifugal forces, but somehow it's not real. Like it doesn't actually amount to any real force. I don't know, man. I don't get it. But I'll post it. I don't know how you can have real forces and also act like they're fictitious. It doesn't make any sense to me.
That just depends on from which frame you're looking at it. Like if you're looking from inertial frame, then all pseudo forces disappear. They only exist if you're trying to look at from a non-inertial frame, like some frame that is accelerating or rotating. Then you're going to see forces that don't make sense, and those are the pseudo forces. Just a product of your frame not being inertial.
But we're talking about at the quantum scale,
Oh yeah. I don't know anything about that. Like that's way over my head.
Same. I'm not really interested in all that, but I seen a video the other day. I'm trying to find it.
And the physics of subatomic particles that's too complicated for me.
Free Demmoch.
Say Demmoch.
Here's the bullshit that be popping up in my feed, dude.
So how do you turn 3 psi where the psi isn't the mass? So how do you know that that's only 3, or how do you know the amount of mass in there if the amount of mass is every amount of mass? It doesn't make any sense. You're saying the mass doesn't change, but psi does? It doesn't make any sense. So the mass doesn't change from what? What mass is in there then?
It's a closed system. So you have a tire. It's a perfect tire and rim, completely closed. But when the temperature decreases, collisions and the velocity of those collisions decrease. And that's what lowers the pressure.
Right. And that's what they're equating to the amount of stuff in there also. They go hand in hand, because when the tire is deflated, you'll say there's only so many psi in there, meaning there's only this much stuff in there. Now, when it's inflated more, you're going to say there's 35 and not 2, right? What?
No, psi is not how much stuff. Psi is like how much those gas molecules are colliding with each other. That's the psi. So if you cool it down, they're going to collide less. So there's the same amount of stuff, but there's less psi now.
So what'd you make it into? So what did you form? What kind of alchemy did you do with temperature? And what other gas did you make it to? What other denser gas?
Oh, temperature is how much excited the molecules are. So if you cool it down, that means you're making those molecules lower.
Molecules of what? What's in that tire, man? What is that mass? What's air?
Oxygen.
Okay, what's the ambiguous word air? Get away with it, free guys. Air? No, what is that?
Mostly nitrogen and oxygen.
Well, how do you prove that?
I don't know.
That's good that you don't know. I'm glad you were honest. You have no clue what you're talking about. So we still don't know what mass is? So you don't know what mass is. You don't even know what the gas is. You can't declare it one gas ever. It's an ambiguous gas called all gas air. That doesn't make any sense. All gases aren't air. They can't be. They're all their self.
That's right. No wrong.
So where's 100% nitrogen and hydrogen next to each other so we can compare them? So we can make sure what's in that tire.
Oh, it just blew up the air that was outside of the tire into the tire, right? So whatever is outside of the tire, that's the same air. Oh, that's the same air that's outside, right?
Yeah, it's non-existent stuff, air stuff. It does stuff. It has a physical effect, but nobody knows what this magic air is. And it's affected by temperature. Isn't that weird? Sounds like it's energy to me. Sounds like you just changed the potential. Right? The potential build up of resistance in the tire by temperature. You excite it or de-excite it by cold. So why would you guys say mass of gas if you can't figure that out? If you can only figure out PSIs? So you just declared that the gas is crazy excited. It's super gas and can fill everything, the whole Earth. If it's not crazy excited, it's just going to stay low to the ground and get low. Isn't that weird? That's some cool magic gravity gas you guys got. So I can put 1 million pounds of helium inside that balloon as long as it's cold, right, boys? It's going to be awesome. Doesn't matter. You can hold all that. It's just going to change the conductivity or the excitement of the stuff, right?
I think helium compresses into a liquid or a solid.
Yeah. We need a liquid, and that liquid will equal so many psi of helium, I guess.
think that was the helium catastrophe described by Dr. Eric Lerner, his refutation of the Big Bang.
Well, basically, helium is water. It's all under conduction, and the word air is helium, right? How do we know there's not a portion of helium in that magic air word? The stuff that doesn't change, but only psi changes. That's just, I mean, I'm with it. I'm with the excitement or de-excitement of it, and that'll change how the reaction is. I'm with that more than I am the word gravity. And they're saying we have layers of these magic 100% gases. There's hydrogen here, argon, helium, nitrogen, or really, all the gases stacked somewhere. Doesn't even exist. It's the word air. So it might seem like I'm off topic sometimes, but it's not, because it brings it all right back together. How do we know what's in that tire? And how do we know
Put it
the
in there, you
amount?
should know.
Well, no. No, we only know that we had a certain temperature and sealant controlling the excitement of this. We don't know how much. We just know how excited, right? Because it's just air. We don't know. We don't know how much of this magic air there is. There could be a trillion% or 1%, depending on the excitement. Correct? Because that would
We
give us
can
the
weigh it.
psi reading. But what are we
You can
weighing
weigh it.
if the gas didn't? Right. If the gas didn't leave, what are we weighing? If the
Well,
gas
you'd have
didn't
to.
leave, what are we weighing? Are we weighing mass or are we weighing excitement or movement of particles? I mean, that's what I'm generally asking. Are we weighing vibration? Are we measuring stationary cold, sitting still, actual weight versus something moving where it's going to be crazy and act a little different and way different? It's the same. It sounds the same to me. So if I got a wiggling bowl of Jello versus a stationary bowl of Jello, they're going to weigh different. Correct?
It's not the same.
Yeah, it's the same bowl of Jello. That's what you guys are declaring. You're saying, Demmoch, I got 5 pounds of Jello here. One is cold and sitting still, correct? One's still and it's cold. It's not moving. It's not excited. And then one's heated and excited and wiggling. So you're moving it, wiggle it, right? And now that one's going to weigh different. I can show you both of these doing the same thing that's being exclaimed to me right now with Jello, with a bowl of Jello, the same amount of Jello. The Jello didn't change, but the temperature or the movement did.
Quote a famous
And they're both.
carpenter. Is it you that says it, or is it someone who told you?
Oh, I can. Huh? I say everything I'm saying. I don't know about you. I didn't read. I
Oh, I
didn't
thought
read
you
these
said
big
I
ass
brought up the
books on
Jello.
military test. I told you about the Jello. That's Demmoch. I don't remember reading about
Okay.
Jello in a
I
book.
you said
Carpenter
I
told
said
you about
something about
Jello in a
Jello.
book.
No,
Some other guy told you about Jello.
you
Oh, me. Well, write it down then. Put it in a book. That makes you feel better that
brought
you
it
read
down.
it out of a book from Demmoch. Does that make you feel better if I put it in a book?
Sure.
It'll make you comfortable. What if they put it in school tomorrow? Demmoch said Jello and he's right. Then what? Then what would you guys do? Go back to the same thing and say I'm wrong? That'd be weird. That's
Oh,
what happens
a
here,
bowl of
though.
Jello is
Nobody
not the
has a
same
memory.
thing as a tire.
Well, what's a memory? Does anybody have a memory? So when you use your memory, do you remember that there's 5 pounds of Jello in here? You guys are saying there's 5 pounds of air in that tire, right? Now we changed the temperature or we changed the excitement. You guys said the particles, the movement, right? Correct? You're changing the movement amount, the excitement of the particle, right? Or whatever you're declaring in there, right?
I
No
don't know.
answer.
I just ran over something.
Oh, I'm sorry. Be careful. You be careful.
I'm just looking under my car.
Oh, okay. Just make sure you wasn't driving or nothing because it's crazy out there where I'm at.
Yeah, it's crazy here too.
Yeah.
It's just a stick. Just making sure
Okay.
it wasn't nothing that could damage my car. Just a twig. Keep it moving.
Yeah, no, 100%. No, but I'm saying so. There's this magic word called air in there, and say there's a trillion tons supposedly that you put in there. But the only reason you measured that and say that you imagine that that's a trillion tons of air is because of the temperature is at a stationary rate while you put it on the scale. And if you do it at cold, you're going to get a different PSI, right? So you guys are saying the PSI is just how fast it's running around in the tire, not the amount. You're saying the amount of Jello is not changing, just the movement and reaction of that Jello. Like if I take a 2 liter or a gallon of soda or whatever, and I sit it on the thing and it's stationary, it's all the same temperature, right? And then I shake one and move it. It's going to do the same thing as the temperature. It's going to give you a different PSI reading also.
So it's the amount of mass or matter and the temperature. There's
A
two
million
factors.
percent. Yeah, I mean it has to be because unless Larry, unless you can take 1 pound of air and show that it's a million pounds also just because of temperature. I mean, what? I mean, how? I don't even know. What is the math we're trying to say that we're even quantifying? We're saying the word air, and we're saying the word 5 pounds. That we put 5 pounds of air in here, but the 5 pounds of air is still in there. We didn't take it out. but we changed the temperature. So we basically changed the form of what air was in there to another form of air, right? In a way, right? Like helium turns to liquid, still liquid helium, right? So we'll change it from air to liquid air, correct?
So I think what we're changing is the thermal energy, which in turn changes the kinetic energy. And the kinetic energy is what presses against the edge of the container or the power wall.
Yes, sir. I'm with you. It's just like it's all magnetic, I think. It's all kinetic, yeah, static, yeah.
No,
It's a
not magnetic.
Yeah, it is.
I don't know how. Explain to me how.
Magnetic. It's all magnetic. Everything acts like a magnet, bro. The idea of a vacuum seal, it all acts like a magnet. Electromagnetic. If it's electricity, it acts like a magnet because electricity and magnetism go hand in hand.
We're talking about thermal energy and kinetic energy.
Hold on, Larry. Movement and weight go hand in hand. So if you move something and put it on the scale, it's not going to weigh the right thing. You have to sit it fucking still. You literally have to sit the shit still, right? If the stuff is moving on the inside of that object, you're always going to get a different weight, right? So what you're doing is kinetically moving that shit in there. Is that not right? You're not just shaking the bowl of Jello with temperature, the gas. You're shaking it up, right? With heat.
Yeah, basically.
Yeah, that's all I'm trying to say.
Connect the magnetic part. That's the part where you lost me.
Well, listen, I can't get away from magnetics. That's the part where people lose me, where they say the word gravity and not magnetism, not actual physical things interacting with the field of this and the field of that, or the kinetic energy between the two doing something, right? So the kinetic energy of heat, right, can magnetically do that. Magnetism can go through the material like sound or like energy or anything else. So in a way, they're all the same. The same way I'm saying the temperature is going to control what mass you get. Now, it might not say, okay, we didn't change the 5 pounds of Jello. I know, but it's going to change the reading of what mass you get, the PSI amount, pounds per square inch of something. So now it's not that pounds per square inch, it's less pounds per square inch. But you have the same shit in there. How does that make sense? I still have 5 pounds of Jello, but the thing's telling me I got 3 PSI of Jello instead of the 5 pounds.
Pressure per square inch is the reading of the pressure against the container walls on the inside.
What's pressure mean?
Force being applied to the walls of the container.
Just move. Yeah, movement.
Did someone say, oh God, was that you?
It's movement. So the temperature is magnetic because it creates movement or less movement, just like magnetism does. Any differentials, positive, negative, whatever the fuck that means, more or less, yin yang, high, low, hot, cold, make things happen. When you have those two differentials, anything between or around them are going to react.
Disagree.
You disagree that hot and cold are going to make everything react?
No, I disagree about the magnetism.
Hot and cold
I
are
don't
magnetism.
understand.
They are caused by magnetism. They are magnetism. Just like light is darkness, and the only way you can have a shadow is by having a bright light, and it's outshining itself. So two sources of light make a shadow. Yeah.
Did you say light is darkness?
Yes, sir. The light is the shadow. You can't have a shadow without light. You can't go in a pitch black everything room and create yourself a shadow. I'd love to see you try. Make a shadow without light. People are trying to say a light is not a shadow. That doesn't make any sense.
Shadow is the absence of light.
Nah, that's stupid. No, it is light. It's light outshining itself. It's light.
Come on, see a shadow, it looks dark.
Cool. That's good. That's the way it's supposed to look. So when the light from your back shines around you, that part, and then the brighter part, and then the layers of it interact in front of you, what you're going to get is a shadow of dimmer lights against a brighter source of light. They're all still amounts of light, brother. Stacked. It's just stacked light. It's stacked light. The layers of light that have to build up. So if the brightest source behind your back is close to you, and it hits your back and hits the wall, remember the source of light still is all the way lighting up the whole room on the other side already too. So the brightest source is always on the wall also. So then the part right. So the part that's going around you, yeah, and shining out that way.
It's not the absence of light, it's the decreased amount of light because there's still light. Even in the shadow.
It's stacked amounts of dim light versus a bright light. It's called being outshined. It's the best way I can put it. The light is outshining itself, therefore creating a shadow. Same way it creates a rainbow in itself in clearness, you know.
I appreciate you, Demmoch. I really do, because you think outside the box, and a lot of people don't think inside the box all the time, but really think outside. box, and I appreciate that. So the shadow is not the absence of light; it's the increase of density of light.